In this video, we're going to take a look at an introduction to distributive property. We're first going to look at a basic arithmetic expression. So we're going to evaluate 3 times the quantity of 2 plus 3. We're going to remember to use our proper hierarchy of operations, which says that grouping symbols will change the order, but the order is generally from highest importance to lowest. So powers and roots go first, multiplication, division, then addition and subtraction are the smallest operations. So our grouping symbols have 2 plus 3 inside those parentheses. So we're going to do that part first. So we're going to have 3 times 5. 3 times 5 then gives us 15. We can look at this in a slightly different way to get us to see why the distributive property works. So a multiplication question is the answer to an area question. So I'm going to look at an area model for this. So I'm going to draw a rectangle, and I'm going to have one side be 2x plus 3, and the other side be 3. Then I'm going to split the rectangle into 2 sections, blue section and a green section. The blue section has an area of 3 times 2, which is 6. The green section has an area of 3 times 3, which is 9. If we take a look at this now algebraically, what I started with again was the same thing, but this time I did 3 times 2 first for the area of the blue, and I did 3 times 3 for the area of the green, which gave me that 6 plus 9, which still gives me the 15. You may be asking, why would we ever want to do this? Well, let's take a look at another example. This time, inside the parentheses, we do not have like terms. I can't actually go through and add those terms together. So I can't evaluate this. I don't know what the value for that x is. So instead, what I'm going to do is I'm going to ask you to simplify this expression. I can't simplify inside the parentheses because the terms are not like terms. But I can still look at this area model idea. One side is going to be 3. The other side is going to be 2x plus 3. Split it into 2 rectangles, blue and green, and we get 6x for the area of the blue and 9 for the area of the green. So if we look at this algebraically, what we did to get the area of the blue was we did 3 times 2x. What we did to get the area of the green as well was 3 times 3. That gave us the 6x plus 9. I can't actually combine those terms together because they're not like terms, so that is the most simplified version of this expression. Just a reminder that at any point you can pause this video to copy down a slide into your notes. Let's look at another example. This time again, we're going to simplify, but we have an x term and a y term, 2 different variables. I again can't simplify inside the parentheses though because they are not like terms. But I'm always looking inside those parentheses to see if there's anything I can simplify first. So I look at an area model. One side is 4, the other side is 3x plus 7. So I'm going to look at the algebra and connect it with the visual as we go. So first I'm going to do 4 times 3x to give us this blue area. And the green area is going to come from 4 times the 7x. Multiplying each of those pieces together, we get 12x and 28y. So our final answer is 20x plus 28y. Looking at the arrows I'm drawing on top, they're showing me what I'm actually multiplying. So the blue arrow goes from the 4 to the 3x, that's what I multiplied first. The green arrow goes from the 4 to the 7x, that's what I'm multiplying next. I'm multiplying the 4 by each term inside the grouping symbol, inside the parenthesis. This middle term here is a working line. Once you get used to dealing with distributive property, you won't actually need to show that middle step. But for now, you can show it until you get used to it. For our next example, we now have a variable term on the outside, a monomial on the outside of our parentheses. So we're going to do a monomial times a binomial. Again, we can think about it visually, 4x on one side, 3x minus 7 on the other side. We can split it into 2 rectangles. The first rectangle is 4x times 3x, which gave us that 12x. Notice I'm skipping that working line. You can still show it if you would like. For my green section, it's 4x times negative 7. That gives us negative 28x. Those are not like terms. Even though they both have x's, x squared and x will have a different value. So it's not 12 of one group minus 28 of the same group, but it's 12 of one quantity minus 28 of a different quantity. So we can't combine those two things together. If we step it up a notch now and we look again to simplify, but this time we have 3 terms inside the parentheses. So since we have 3 terms, we're just going to multiply 3 times. It's the same idea as before. So we take the monomial out front, multiply it by the leading term of our trinomial. Then again, we take the monomial out front, multiply it by the middle term of our trinomial. Last time, we take the monomial out front and multiply it by the remaining term in our trinomial. Notice I put pluses in between because I'm also doing this, and the green, and the red. You can tidy your signs right in there if you're thinking ahead, and you can just have a subtract if it ends up being a subtract. Again, this is a working line that eventually you won't be showing anyway. Once we actually do the multiplication, to do our multiplication, we're multiplying our coefficients. So for that first term, negative 2 times 5 gives me negative 10. And then we're multiplying our variable part. X times x squared gives me x cubed. We add our exponents when multiplying variable parts. Similarly speaking, with the green, we have 4x squared. Notice it's negative this time because negative 2 times positive 2 gives me negative 4. The last term is positive because negative 2 times negative 4 gives me positive 8. If we wanted to take a look at a visual to represent this, we would just have 3 sections to our rectangle. Again, each section, each length of each section would represent one of the terms in our trinomials, and the areas would end up being the final terms in our trinomial answer. Okay, last one. This time we're going to put a little bit more going on. We're still going to simplify, but now as you can see, we've got 2 sets of parentheses in there. We're still going to use our hierarchy of operations. Even though this is algebra and not just evaluating, we're always thinking about our hierarchy of operations in mathematics. So again, grouping symbols messes everything up. We do that first. There's nothing I can do inside these grouping symbols, however. There aren't like terms, there's no multiplication that I can work out, there's no roots or powers that I can actually do. So then we look at what's next going down our hierarchy of operations. The largest operation, the most powerful operations are powers and roots. There's nothing I can do with powers and roots in here. I have some exponents, but I can't work them out because I don't know the value of the variable. Next up is multiplication and division. They're our next powerful operation. Multiplication is what we're doing when we're doing the distributive property. So that's what we're going to do next. We are going to multiply the 4x times that quantity inside the parenthesis. We are also going to multiply the negative 6x squared times the quantity inside the other parenthesis. So let's start by doing that. So 4x times 3x gives me 12x. 4x times 2x squared gives me 8x cubed. Negative 6 times 3 gives me negative 18. X squared times x gives me x cubed. Negative 6 times negative 4 gives me positive 24. X squared stays as an x squared because I'm not multiplying it by any more x's. Usually after we do the distributive property, we're done. But there's one more step on our hierarchy of operations. That's addition and subtraction. That's the smallest type of operation. So is there anything I can do with addition and subtraction? Well, hopefully you notice that the 2 middle terms in this case are actually like terms. I can combine those together. So if I take positive 8 and negative 18 x cubes, I end up with negative 10 x cubes. The orange term for x squared terms and the x terms don't have any like terms that go with them, so we just write those out. Notice the order that I wrote the terms in is decreasing degree. The degree comes from the exponents on your variable part. So cubed, squared, then to the power of 1. That's all for today. Again, remember you can go back and pause the video to add any of this to your notes.